My experiment is about the temperature change and its effect on electromagnets. My abstract, does the temperature of an electromagnet affect the strength of the magnet itself? I've always found electromagnets extremely interesting. Just the fact that running electricity around a nail or some kind of iron creates a magnetic effect is just really fascinating. And that's why I chose to do this experiment. Now, for my safety and error reduction, there were a number of things I did have to account for. The first thing was the handling and storage of the dry ice. Um, when I bought the dry ice from the store, I did also purchase a styrofoam container to keep it in, because I don't really wasn't wanting to just put it in my freezer or anything like that, where it would come in contact with anything else. So I made sure and stored it in that styrofoam container. Now, when I started handling the dry ice, I made sure I used cooking mitts or tongs, long metal tongs, like the kind you would use for a barbecue pit that had rubber handles, um, and just to make sure I didn't get anything on me. Now, I also had to be very specific about the clothing I wore. I made sure and wear closed-toed shoes, in fact, rubber-soled shoes, um, and I also wore a long-sleeve shirt, long pants, um, and made sure my entire body was covered up as best as I could. Um, Now, for the electricity, that one is another one we had to be very careful for. The first thing was picking the correct surface to do it on. I just used my tile floor. It seemed like the best possible surface. Um, and then the shoes, as I said, I had rubber-soled shoes. And in order to, when I was connecting the battery to the electromagnet, I was using insulated alligator clips. Very, very careful with those, and just to make sure I didn't electrocute myself. Now, there was a couple things I needed to be mentioned about error reduction. The first thing was the staples themselves that were being picked up in the experiment. They had a tendency, if they weren't split up enough, to kind of hook on to each other, so that it was hard to ensure that it was the magnet picking it up instead of just the fact that other staples were hooking onto each other. So what I tried to do there was spread them out as much as I possibly could, but within a small enough distance so it's not going back and forth over a large distance. Now, for my experimental procedure, the first step was building the electromagnet, and I have a couple images there. You can see the diagram there, and then you can see my actual entire setup. Now, in order to build the electromagnet, all I did was I took an iron nail. It was about 3.5 inches long, and I wrapped a thin copper wire around it, thinly insulated copper wire. This is very important to mention that it was very thinly insulated. So I wrapped it around there as tight as I could, as you can see from the image there on the right. And what I did was you have to make sure that it's all going the same direction and it's not overlapping or anything like that. You also have to leave enough copper wire on either end in order to connect the battery to it. Now, when before we did connect the battery or anything like that, we had to make sure to heat or cool the magnet. Now, in order to heat the magnet, that was pretty easy. I just had a little butane torch and just got it nice and hot. Took temperature with one of the laser thermometers, and that was that. Just did that for all the necessary temperatures. Now, to cool it, what I did was I put it in dry ice for about an hour or so, just to make sure it got cold enough, and I would then measure it. In the first trials, where I used dry ice, obviously I did the trials immediately after pulling them out of the dry ice after I took the temperature. The other ones I would let them warm up a little bit until they got to the correct temperature, um, and then I would connect the battery and perform the experiment. Now, connecting the circuit is pretty simple. If you can see here on the image on the right, I have those two alligator clips, the insulated alligator clips. I would connect them to the electromagnet first, and then I would go ahead and connect them to the battery, as you can see in that image. And then I would run the staple for each trial. I would run the magnet itself over the staples that I had spread out over the floor, and I did that 5 times for each temperature. And then I just recorded the weight of the staples picked up. Pretty simple. Now here I have my results. As you can see, the various temperatures I used, I went from -75 to -50, -25, 0 to 25, 50, 75, and 100 degrees Celsius. And you can see the weight of the staples that were picked up there. I also have my standard deviation and my standard error, which for the most part is pretty small, which was nice. Uh, as right below that, I have my t-test results. I have my temperatures on the left-hand side, the ones I was comparing to one another. Then you have the t values. Most of them not very significant until I start looking at 0 degrees and 25 degrees, and 25 to 52 a little bit. But the 0 to 25, there's just a really big jump. So you can see the p value is really, really small. The t value is very large. And you'll see that in this next graph here, that you can see the jump from 0 to 25 degrees. It was quite large. Here is the graph of the data I had. As you can see, most of the errors are really small. Like if you look at the -25 degrees and the 50 degrees and the 75 degrees, they're all the error bars, you can barely see them. They're so small. But they're there. They're all there. And they're all a little different from point to point. But you can see the major jump from 0 degrees to 25 degrees. Very, very large jump in the amount of staples it was able to pick up. Now for my analysis, we saw an increase in the temperature leads to an increase in the power of the electromagnet, and this rejects the null hypothesis. As you can see, there's that significant jump in power from 0 to 25 degrees. Yeah, it was just it was between -75 to 0. The increase was gradual, same from 25 to 70 or to 100. It was very gradual. There's just that one huge jump there, one big jump.